Hello YouTube viewers, welcome to my show Computer Wednesday. In today's episode, we're going to talk about NVIDIA Jetson Nano. So let's dive right into it. So first thing you have to understand what we are talking about when we are talking about Raspberry Pi or other things like that. We are talking about self-contained system. Now, if you are familiar with computer, you must understand that there is processor, there is RAM, there is graphics card, there is modem, hundreds of things. They are all separated out. When we are talking about self-contained system, it is generally pack all of those things in as small package as possible. So you must be aware of Chiron systems, you must be aware of A9, Exynos, Snapdragon 800, all those things. Basically, they are system of chip. What does that mean, system on chip? Basically, as many things that is small things are there that can be cramped into the system, they will cramp it. Basically, let's say you have a processor that's dedicated for fingerprint management, it will be put into the processor. You have basically Wi-Fi router programming system. Your router also has a basically processor core, a small one, but it has it. That will be also put into the system. You have graphics card, that will be also put into the system. You have processing unit, central processing, that will be also put into it. You have mobile network configuration system, that will also require a processor, you will also put that in. So this is what we classify as system on chip. The only thing we generally try to keep out of system of chip is generally RAM modules. There are two primary reasons for. First is physically way too big. Second, when you're talking about RAM on basically RAM things, company want to control it. Basically, if you buying any Samsung mobile phone or any other things like that, even Apple, you will be like, okay, 2GB variant, 4GB variant, or in case of Apple, there would be like, okay, 32, 60, 16 and things like that. So that is why some things are not kept into the chip itself. They can do it, they just don't want to do it because it's very demanding physically, and they want to give manufacturers option. So this is why we have system on chip. This is what you have in your router. This is what you have, like, of course, high-end professional router. I'm not talking about a router that is in your home. That's a very low end. So Cisco routers that are used in enterprise grade, which has like a freaking AI into it to figure out how, even if you are using VPN, it can predict the traffic, whether it's a virus or not. So those kind of system requires a fully integrated computer. And when you are talking about, that is system on chip. When you are talking about single board computer, you are talking about Raspberry Pi. Basically, they took this and sorted it as small board as possible. So you will have your input, output, power management, all of that in one board, Raspberry Pi. Now, there is a bridge between these two, because you can understand, what if you don't want USB ports in your basically Raspberry Pi? All you want is Ethernet. Let's say you are making a router or SPF, PF routers, something like that. So you can check my video here. If you are doing something like that, you don't need USB port, but you need Ethernet. You can't change it here. However, to bridge that gap, basically taking a chip and directly soldering it out, or buying this and modifying this, somebody came up with this idea which we call system on module. Now this is becoming very popular in recent years because there are many things that upgrade very slowly and other things that upgrade very fast. So let's say your computer module, that's upgrading very quickly nowadays. However, let's say you are making a TV. If you are making a good, like let's say a panel that is 4K 60 FPS, good color dynamic and all that, you're gonna keep selling that for let's say another 5 to 6 years. However, the computer and processor, they will keep getting upgraded very quickly. So what you will do in your basically motherboard of the basically your TV, you will have a module place where you're just gonna plug the module. So let's say you will use one module for 2 years, and then let's say market competition is catching up, you will change the module itself. You will not touch the system, you will just plug the system up, place the new system in. And this is not like a processor slot, because it has everything on it, basically from RAM to processor to graphics card, all of the things. Basically, this is a bridge between single board computer and system on chip. So this is system on chip made into a module, so you can just put it into the system whatever you want. So you can buy 2GB variant, 4GB variant. You may buy a variant that has very high-end graphics. Other time you may buy something else. So this is what we are talking about when we are talking about NVIDIA Jetson Nano, the system on module. So what the heck is this system, NVIDIA? Basically, NVIDIA is jumping seriously into AI. So they want to, entice people into their platform. So the price of this NVIDIA Jetson is an old system. Now, when I say old, it's not like, it's more like an architecture they have been developing in the background. Now, early days, the platform cost was like $300 to $20,000. So you can understand many people were like, yeah, we can't test that. Even university had hard time to, grasp it. So they're taking a lesson from Raspberry Pi. They created a development system for $100. Now this is very amazing, because what they are doing is they have the module and they have development kit. So they are selling both of this. So it's not like you're getting one without the other. You are getting the whole package. You are buying this, and you basically have a system on chip on your development board, so you can develop whatever you want. This board itself will give you the pin out, so that's why it has four, understand, four USB 3.0 ports, and dual display output. It has display port and HDMI full size, you don't need adapter for that, Ethernet system, and GPIO pin. So if you have, like, let's say LEDs for display, status display, you can take care of that. It also accepts a camera for direct camera integration for, let's say, you want object recognition and things of that nature. So that is what NVIDIA is doing. So at this point in time, at this cost, this is the cheapest high-end system you can get for AI researching. So whenever you hear people say, like in, like, Apple conference or Hawaii conference, where they are talking about, like, this processor has neural engine, neural core, neural network processor, this is what they are talking about. So at this point in time, for consumer, like from you and me, this is the best option we have if you want to learn about those things, if you want to develop your deep neural networking abilities. Now, to give you a context of its capability, how much capable it is, because the price is not that drastic, especially if you are talking about basically 4GB variant. This is also 4GB, so 4GB variant is like $55, this is $100, so it's not that much. However, when you're talking about flops, basically how much crunching, number crunching it can do, Raspberry Pi 3 is rated, so 3 only goes 3 plus only goes up to 6 to 7 gigaflops. However, let's assume that Raspberry Pi 4 is very high power. Under no circumstances that can exceed 20 gigaflops. 20. This puppy goes to 472 gigaflops. It's almost half basically teraflops. To give you a context, that's a GTX 1070 kind of power. Now, of course, one generation back, because GTX 1070 I think is like 1.5 teraflops. So you can understand this is like literally a full-end desktop grade processing power. Like in terms of many low-end basically laptops have that kind of power. So it's really powerful, and given the fact that it only requires 10 watt at maximum performance, so that also means this another fact that it is very efficient with that power. So let's say you built a laptop for something, this will not drain your battery very quickly compared to Raspberry Pi, because it's much more efficient with the power. The power is very high, so even though price is only twice as high, or even 3 times if you are buying a very cheap version, and it does come with 4GB NVRAM. Now that NVRAM is very critical aspect, because you're not supposed to basically sell products with this thing, basically the kit that you can buy from Amazon or anywhere like that. What you're supposed to do is, once you have built your thing, basically you figure out the module, you did the coding, you use this, you built your own PCB that you're gonna sell, you're gonna go with NVIDIA. It's like, hey NVIDIA, I need, like, let's say 800 of those modules. So what will NVIDIA do is, like, give you a cheaper module. That module will not have SD card into it. The reason for that, NVIDIA is using NVRAM. So NVRAM, the RAM itself is permanent, 4GB of permanent RAM. So that will give you a very quick startup and slow down, and you don't have to worry about memory basically. And those will be cheaper, because if you're buying, let's say 800 of that, NVIDIA will give you a bit of discount. If you're buying 20,000 or 30,000 of that, for, let's say, you're making an Amazon warehouse robot, they're like ordering in 50,000 or 60,000 like that, in those sort of scenarios, NVIDIA will give you a bulk discount. So that is the whole point of this, the module. So why the hell NVIDIA is doing this? Why? Like, why if you have such a big community, because there are many competitors of Raspberry Pi and almost all of them have failed, even from Asus, simply because you need community. When you're talking about tinkering, when you're talking about, like, developing something, you need community. The sole reason Neelex is such a powerful system is simply because there are so many people pouring their heart and soul into it. That's why VLC is so popular, popular and powerful. So this is trying to do that for AI. If right now, if you want to do AI, you have two options. You simulate, like, you buy a very powerful computer and simulate it, simulate it AI core in a virtual world. That does work. If you have powerful computer, that's awesome. However, that powerful computer can be, like, you can literally overpower it by using few watts of power if you have dedicated neural core. That's why Intel also is jumping into this. Intel also released, if you are familiar with this, I think 1 year ago, the USB stick that was compute core in a USB stick. This is like a full computer with neural network. So if you want to learn, understand how the heck deep neural network works, this is the best tool for you right now. At this point in time, this is the best tool. And to give you a context, NVIDIA already is providing developer kit. They have a neural network that is pre-trained, so you don't have to worry about training. And if you just want to see the output of it, you can just feed it in image using a camera or direct image itself, and it will tell you it's a dog, it's a boy, or it's a wooden spoon, or things of that nature. I have provided a video down below. You can check that out for yourself. So it's a really good tool for those kind of understanding. If you really want to understand how the heck, let's say, if you're thinking about AI, you must be thinking about like big computers, big processor, and it does take that if you're doing it in your computer. But when you're talking about dedicated processors that are built for that, it's surprisingly different. Like it's like to do same task on a computer, it takes like, let's say, 50 watts. To do on a chip, it takes barely 1 watt. So that is why. And it also has GPU parallelism, so you have to understand it has like 128 CUDA cores, so it's a really large amount of parallelization. And if you can parallelize for 128, you can really utilize much more things than that, because there is upper versions of these things also. So, and this image recognition system, they pre-built it, so you can directly jump into the fray, train the network, and then develop a neural network that you can send to other things, or buy the more modules and build a product out of it. So to give you a utilization, like how these sort of technology is being utilized, one of these technology is this drone. Now the funny thing about this drone is completely autonomous, and it's autonomous not by using ultrasound or things of that nature. It's autonomous by using cameras. It has 12 navigational camera. Now you're not supposed to see the video out of it, but these black and white camera is doing, it's making a 360 3D sphere, and drone is utilizing this to avoid tree branches, because you must be familiar with the fact that ultrasound is very good for telling where the ground is, but it can't do much about in terms of basically tree branches and forest, but this can navigate that. Now when the developers were building this, they were like, computer itself weighs so much that there like 15-20 minutes of run time is reduced because of the weight of the computer. So you have to understand that these sort of technology requires AI understanding and integrated processor. You can't like the AI that you build for your PC will not work on this. You have to have something dedicated. So this sort of there are some companies that are building guard dogs, basically using AI itself, so it can do facial recognition. So customers will not get harassed, but like somebody is coming from let's say somebody's face is run through a facial match from criminal record and criminal records for it, so these will stop them. So you need basically AI processing for that. Can Raspberry Pi build a dog? Yes. Can Raspberry Pi facial recognition? No. That's the whole point. As you can see, this is the whole point of this: image recognition, GPU parallelism, and deep neural network. If you want to learn those things like high-end, basically current gen technology, you have to have this. So let's talk about the uses of this. Like first thing, foremost, the biggest warning anybody is going to give you, it's not a better Raspberry Pi. So if you think, okay, there is a Raspberry Pi, I want to buy a better Raspberry Pi, this is not it. Can you use it as a computer? Yes. Can you use it as a better Raspberry Pi? Yes. But you have to understand it does not have community. So if you are having, let's say, GPU pin header issue, and you are like, hey, I want to put a real-time clock into this, the compiler may not work. So you have to understand this. It does not have a community with it. Like, of course, there is a community, there are people working on it, and NVIDIA itself is pouring enough money that they are developing very good tools with it. But there is not a big community. Like if Raspberry community has like, let's say, 10 million users, this barely has 1 million, barely. So, and you have to understand, those people are like from university or less, so they are not making large YouTube videos. So it's not that. However, if you truly want to understand AI, you have to have something like this. As of now, this is the only option, and this is the path for autonomous vehicles. So if you see people like showing how AI car sees the AI sees the car to make a decision, you must have seen something like this. Like it makes a box, it's like, okay, this is a big car, heavy car, slow down, rate distance, all that. How those things are happening? Those are happening something like Jetson. Now you can buy even higher version, basically 10 teraflop version, which is like a much more powerful than any computer right now, common use computer. So you can buy this, and these are actually used in actual autonomous car. So let that sink in. So that is why NVIDIA is making such a good small form factor system for you. So like they want you to buy it, they want you to learn it, and once let's say you are making your car company or you are working somewhere else, you can say, hey, buy NVIDIA system, I am familiar with that. Or like say there is much more room, like developed codes for NVIDIA system, just use that. So NVIDIA is like playing from all sides. They have a high-end system which let's say you are making something, let's say China's facial recognition system, you can utilize high-end one. You want to do just facial recognition for, let's say, 50 people or 60 people, you can utilize the small one. And you can already see, like Amazon robots are already powered by something like this, and sometimes they are directly using this processors. So this is what the use case of it. It's not meant for like, okay, I'm gonna turn on LED or turn off LED. That's not what it's meant for. Like you can do those things, undeniably so. Can you use this as a computer? Absolutely. It's much more basically usable, practical. In practical terms, you can use it much more efficiently than a Raspberry Pi. However, it's still not a Windows environment, still has a Linux environment, and still has a lower different architecture. So you must not think of it as that. Can you use it? Yes, but you are just wasting money at that point. So that is the use of it. You want to learn AI, you want to learn how autonomous vehicle works, please buy this. If you want to, if you have some other tool that you are using, please tell me in the comments below. So this was my presentation about NVIDIA Jetson Nano. I hope you liked it, learn from it. In that case, please click the like button. If you didn't like it and also hated it, you can press the dislike button. I would urge you to press it twice to show me your extra disappointment. And please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.